Hello students, welcome to the class on control engineering. So in this problem or in this video, we are going to solve another problem related to Bode plots. So the problem is been given like this. So we are going to do the step-by-step method to draw the Bode plots. What is the step number 1? So we are going to convert the given standard form of g of s into h of s into time constant form. Let us see how to do it. So this is g of s into h of s which has been given. So g of s, the unity feedback system, that is h of s is equal to 1. So that is equal to 800 s plus 2 divided by s square s plus 10 into s plus 40. So this is a problem which has been given. So we are going to convert this. So 800 out from this I am going to take 2 as a common. So 2 1 plus s by 2 after taking the common 2. Next s square. So from this I am going to take the 10 as common. 10 1 plus s by 10. From this 40 as common. 40 into 1 plus s by 40. So after simplification, so I got 4 into 1 plus s by 2 divided by s square 1 plus s by 10 1 plus s by 40. So this is a g of s into h of s is equal to this value. So this is what converting from the given standard form to time constant form. So this is step number 1. Okay, next step number 2. What is step number 2? Identify the various factors and find out the corresponding corner frequencies. So the first factor that we need to find out is a k. So from this, what is the value of k? K is equal to how much? 4. Okay, next we need to find out the number of poles or number of zeros at the origin. So here we have poles at the origin, that is s square. Okay, how many poles at the origin? There are 2 poles at the origin. I hope you got it. So s to the power of 2, that is equal to 0. There are, this is the first factor. Second factor is 1 by s square. So we don't have zeros, right? 1 by s square. 2 poles at the origin. So this is the factor number 2. What is the factor number 3? We need to identify the number of simple poles or zeros and corresponding corner frequencies. We have simple zeros are there, simple poles are there. The first one is third factor is simple 0. So that is equal to 1 plus s by 2. So I need to find out the corner frequency, that is equal to omega c is equal to 1 by t. So what is t here? T is equal to 1 by 2. Therefore omega c is equal to 2 radians per second. 2 radians per second. What is the fourth factor? So we have a simple pole. What is a simple pole? We have 1 by 1 plus s by 10. So what is t? 1 by 10. So omega c is equal to how much? 1 by t, that is equal to 10 radians per second. Then fifth term, simple, another simple pole, right? Another simple pole. What is the contribution of this? 1 by 1 s by 40. So t is equal to 1 by 40. Therefore omega c is equal to 40 radians per second. Okay, we got 3 omega c. Out of this, which is the smallest, 2 radians, that is the omega c1. Another smallest, that is the another next number is 10, that is the omega c2. Next highest number is 40. So therefore omega c1 is equal to 2, omega c2 is equal to 10, omega c3 is equal to 40. omega c1 is equal to is due to the simple 0. Omega c2 is equal to 10, that is with the help of simple pole. Omega c3 is equal to 40, that is also with the help of pole. So this is very much important. Okay, what is step number 3? So after this identifying the factors, the step number 3 is the steps to write the magnitude plot. Okay, what is step net? Magnitude is equal to 20 log k to the base 10. Step number 3, magnitude plot. What is magnitude plot? Magnitude, that's the first factor, k. What is the value of k? Is equal to 4. So magnitude is equal to 20 log k to the base 10. So 20 log how much of k? That is 4 to the base 10. So how much we got? So this is equal to 12 dB. So I am going to draw a line above the 0 dB line, okay, because k is greater than 1. So I am going to draw a line parallel to the 0 dB above. Okay, so that you have to write it. Draw a line parallel to 0 dB at 12 dB. Okay, so it will be, line must be above the 0 dB line. How to represent this in a semi-logarithmic sheet? See, already I am ready with the initial preparation that I have to make. I have marked 0 dB and also 20, 40, 60 dB plus and also minus 20, minus 40 dBs. So graph is ready. So now I need to mark it. Okay, so here the one unit is divided into 5 parts. So therefore each small unit represents the 4 dB. Okay, so now how much I need to measure? I need to measure 12 dB. So therefore I am going to draw a first mark 12 dB from 0. This is 0, 4, 8, 12. This is a 12. Okay, from here I am going to draw a line like this. Okay, so this is a 12 dB. Okay, magnitude. So from 1 radian per second I am going to draw a vertical line until it touches the 12 dB line, this point. So this is the magnitude k, contribution of magnitude k to the magnitude plot. Okay, next factor. What is the next factor? Let us see. So we have the next factor, second factor in the step number 3. So what we have? So how many poles at the origin? 2 poles at the origin. So what is the contribution of poles at the origin? One pole contributes minus 20 dB. So here we have 2 poles at the origin. Therefore n into 20, that is 2, minus 2 into 20, that is minus 40 dB per decade. Okay, that I am going to mention here. We have 2 poles at the origin. Contributes how much? Contributes minus 40 dB. Therefore draw a slope of minus 40 dB from where? From the magnitude of, from 12 dB, from 12 dB line until corner frequency 1, that is omega c1. What is the corner frequency 1? We found out omega c1, that is the corner frequency 1 is equal to, wait a second, okay. omega c1 is equal to 2 radians per second. 2 radians per second. So, okay, how to represent this in a magnitude plot? So let us consider this. So first we need to mark the corner frequencies. What is the corner frequency? 1, that is 2 radians per second. So I am going to draw a line, vertical line above. So this represents 2 radians per second. So next omega c2 is there, that is 10 radians per second. So I am going to draw a line above. This is a corner frequency 2. Next, what is our corner frequency? 3, 10, 20, 30, 40. That is a 40. So this is a 40. So this is omega c1, omega c2 line. This is a omega c3. Okay. Omega c1 corner frequency 1 is due to the 0, very much important, simple 0. So this one is simple pole, and this is also simple pole. So this is very much important. Okay. So now I need to locate 2 poles at the origin. So it contributes how much? Minus 40 dB. So therefore what I need to do, from this point where I have identified in the previous step, so I am going to draw a line parallel to slope of minus 40. Okay, this is a slope of minus 40, and I am going to extend the same until it touches the corner frequency 1. I hope you got it. So this is red line represents the contribution of k and 1 by s square, 2 poles at the origin. Okay, next, what is the next step? Third factor. What is the third factor? So this line come across at omega c1. We come across what? Omega c1 2 radians, we come across a simple 0, that is due to simple 0. What is the contribution of simple 0? See, simple 0 contributes how much? Plus 20 dB per decade. Okay, simple 0 contributes plus 20 dB per decade, a slope of plus 20 dB per decade. Therefore resultant slope will be previous slope. What is the previous slope? It is minus 40. Contribution from simple 0, it is plus 20. Therefore the contribution is what? Minus 20 dB per decade. I hope you understood. So omega c1 is equal to 2 radians per second. It is due to the simple 0. Simple 0 contributes plus 20 dB. Previous slope is minus 20. After simplification we come across what? Plus 20. Okay, what to do? So I am going to draw a slope. I am going to draw a slope of how much? Minus 20 from the corner frequency 1 until it touches the corner frequency 2. Okay, so this is a slope of how much? Minus 20. So this is due to the contribution of k and 1 by s square and simple 0, 1 plus s by 2. Okay, so at up to omega c2. So omega c2 is a simple pole. Okay, fourth factor, that is at omega c2 we come across simple pole. So as per the steps, what is the contribution of simple pole? It is going to contribute minus 20 dB per decade. We come across simple pole, contributes how much? Minus 20 dB. So therefore resultant, what is the resultant? Previous slope is minus 20. This is going to contribute minus 20. So therefore it will be minus 40 dB. So what to do? So therefore from the corner frequency to I am going to draw a line of slope of how much? Minus 40, like this, and move it, and I am going to draw a line. So this is a slope of minus 40. This is slope of minus 40. This is due to the contribution of what? K 1 by s square 1 plus s by 2 and simple pole 1 by 1 plus s by 10. Okay. Next, what next? So at omega c3, fifth factor omega c3, we come across what? Another simple pole. So it contributes how much? Minus 20 dB. Therefore resultant is equal to previous slope is minus 40. This contribution is minus 20. So minus 60 dB. So what now? Now I am going to draw a slope of minus 60. Okay. So I am going to draw a slope of minus 60 from omega c3 up to some extent. So this is a final slope. This is due to contribution of all 5 factors. Okay. Slope is minus 60 dB. Okay. So this is the magnitude plot is over. I hope you understood. So next thing is we need to do the phase angle plot. So that is the step number 4. Okay, phase angle plot. So for this, what we have to do? We need to prepare a table. Okay, what table we have? So first column will be omega. So we are going to vary the value of omega from 0 to infinity. So we have 5 factors. What are the 5 factors? K is there, right? Then we have a two simple poles, that is 1 by s square. Then we have a simple 0, that is what is simple 0? 1 plus s by 2 simple 0. Next we have a simple pole, that is 1 by s by 10, right? Correct. You can take this one. So we have 5 factors, that is k, and a simple pole, 2 simple poles, simple 0, 2 poles at the origin, simple 0, simple pole, and another simple pole. Another simple pole 1 by 1 plus s by 40. Okay. Next, this one. So this will be plus, okay, plus tan inverse of omega by 2. This will be simple 0 pole, right? So this is simple 0. That's why it is plus tan inverse of omega by 2. This one is minus tan inverse of omega by 10. So this will be minus tan inverse of omega by 40. And the last column will be resultant. So we have to prepare the table like this. Okay, we have to prepare the table. We have to prepare the table like this. So what we have? So here we are going to vary the value of omega, that is 0.2 to 10, 20, 50, 100 and infinity. So like this we are going to vary any random numbers. You can take one from the smallest to largest. Okay. Now let us see the contributions of various things. So what is the contribution of phase angle plot? Okay. So K is how much? K is equal to 4, right? So value of k is equal to 4, right? K is equal to 4, that is it is greater than 0. It contributes how much? For all the values of omega, k is contribute 0 degree, 0 degree, 0 degree, 0, 0, 0 and 0. Next, poles at the origin. One pole contributes how much? Minus 90. In this case, we have how many poles? 2 poles. Therefore, the contribution will be n, that is 2 into 90 minus 180 degree. So, for all the values of omega, it is going to contribute minus 180, 180, minus 180, minus 180, minus 180, minus 180 and minus 180. Now here is the term. So we have a simple 0 contribution is plus tan inverse of y by x or plus tan inverse of tw. So that is what I have written. Next we have a simple pole. What is the contribution of simple pole? It is minus tan inverse of tw. So that is what we have written, and minus tan inverse of tw for simple poles. Now for each values of 0.2, what are the contributions? So I have already calculated. So this will be plus 5.7. This is minus 1.14, minus 0.28. The resultant is minus 175.72. When it is 2 degrees, 2 radians per second. So this value is 45 degree, and this one is minus 113 minus 2.86. Therefore the resultant is 149.16. In the same way, when it is 10, so it is 78.6. So this is minus 45 minus 14.3, and the resultant is minus 160.43. When it is 20 radians per second, this value is 84.28. This one is minus 63.43, and this one is minus 26.56. The resultant is minus 184.71. Next, when it is 50, this is 87.7 minus 78.6 minus 51.3. Resultant is minus 222. In the same way, last 100 radians per second. So this will be 88.85 minus 84.28 minus 68.19. So this will be minus 243.56. Next, when it is infinity, so this will be plus 90 minus 90 minus 90. Resultant is minus 270. Okay, so this is the table that you have to prepare. So phase angle plot. So now I am going to mark all these points when it is omega is equal to 0.2. Okay, 0.1, this is a 0.2. Value is minus 175. Minus 175. Somewhere this is 175, right? Somewhere here I am going to come. It is going to come here. Okay. When it is 2 radians per second, this is a 2 radians per second. The value is 149, right? Minus 149. Just 2 radians per second, 149 somewhere here. Okay. When it is 10, it is 160.43. So 160 when 10, it will be 160, right? 160. So somewhere here I am going to come across 50, 60. Okay, somewhere here. Next, it is 20. I am going to come across 185. 185 when it is 20. 10, 20. So 185. Somewhere here I am going to get. Okay. Next one is when it is 50, triple two minus triple two, 20, 30, 40, 50. Triple two, right? Okay, somewhere here I am going to get. Okay, so this is the graph I am going to get. After this I am going to join this with a smooth curve like this. Okay, so the very much important factor is this: the phase angle plot we need to draw until it should cross minus 180. Okay, so that is a very much important. So this is how I am going to mark the phase angle plot. What is the next step? So next step is to find out the omega GC. How to find out the omega GC? First identify where this magnitude plot is crossing the 0 dB. So approximately here, right? So it is crossing at 2 radians per second. Omega GC is approximately crossing at 2 radians per second. So this is omega GC. This itself is omega GC. Next, what is omega PC? Where actually it is crossing omega PC. I am going to draw a line upwards like this. So this is the omega PC. What is the meaning of omega PC? Where this phase angle plot is crossing minus 180 degree. So 10, 20 approximately at 15 radians per second. It is crossing at approximately at 15 radians per second. Omega GC is equal to 2 radians per second. Okay, hope you got it. Now the next step is to find out the gain margin and phase margin. What is the phase margin? So at omega GC I have drawn a vertical line. It is intersecting this phase angle plot at A and also the reference line at B. So take this measurement. How many units are there? So 1, 2, 3, 4, 5. There are 5 units are there. So each unit represents how much? 6, right? So 5 into 6. Approx phase margin is equal to 6. 1, 2, 3, 4, 5, 6. Okay, 6, right? 36 degree. Okay, in the same way I need to measure. This is a plus 36 degree because I am measuring it upwards. Okay, next, gain margin. What is gain margin? From omega PC, that is 15 radians per second, I have drawn a line upwards. It is going to intersect the magnitude plot at C and this 0 dB line at D. Okay, so take this measurement. So this is a gain margin. Okay, so GM is equal to how much? 1, 2, 3, 4, 5, 6. Okay, here each small unit represents 4 dB. So here 1, 2, 3, 4, 5, 6. There are 6 units are there. 6 for the 24. So 24 dB. So gain margin is equal to positive 24 dB and phase margin is equal to 36 degree. Okay, what are the things we got? Omega GC, that is crossing at the 0 dB, is equal to 2 radians per second. Omega PC that I got is 15 radians per second. Correct, 15 radians per second. Phase margin, that is 36 degree. Gain margin, that is equal to 24 dB. So these are the data I got. So from this So what is the conclusion we are going to draw? That is very much important. Stability conditions, we have three conditions. So out of this, we found out that omega GC is less than omega PC. GM and PM is positive, therefore the system is stable. So this is the final comment that you have to draw. What is that? So omega GC is less than omega PC. GM and PM is positive, hence the system is stable. So this is the conclusion what we can draw from this. I hope you understood. Thank you. Namaste.